Okay, Kevin W. This is your custom Hornet H4. It's an H4 built with 2290s. Okay, Toshiba 2290s. Alright, getting ready to crimp the ends on, but I thought you might like to see the inside of it. More to come. I use a Dorman EC300 electric battery operated hydraulic crimp to do the crimps with, that can put more pressure than one of the hand pump jobs. So I think it works a lot better, gives me more consistent crimps. Okay, let me get set up and I'll show you how it's done. Okay, so first thing I need to do is slide the cable up inside the terminal. Make sure I'm still in camera. Yeah, my big old hand's in the way. Apologize for that. Okay. Need to make sure the wire's all the way inside the terminal, and then squeeze the trigger. There's the first crimp. You guys can see that. Yep. Make sure I got the terminal positioned correctly. Okay, there it is. Two perfect crimps. That's on the positive wire. Now let's do the negative wire. Same kind of thing. What I'm doing there, I'm bunching it up to grab the terminal so that I can push the wire all the way in. And I check, make sure the terminal's turned the right way, because if you crimp it with it twisted, it doesn't want to go in the connector. The plastic Anderson power pole connector doesn't want to go in there straight. So I have to make sure that it's turned the right way. Okay, this time I'll get my hand out of the way. Consistent crimps every time. Okay, just thought you guys might like to see that. Okay, next step in the process is putting some heat shrink over the back of these things, because the power pole connector got pretty big holes there in the back of it, and that's so that you can get good sized wire up in there. But for what we're using, we don't need that big gap back there. So I'm putting some heat shrink around the back end of the terminals to make sure that nothing can get in there and short them out. Weller heat gun. Not a good idea to use butane torch or cigarette lighter to heat shrink. Better to have heat with no open flame. Now the other things do work. I mean, I used a butane cigarette lighter for years to shrink the heat shrink tubing. some more around the end there. Okay, now we're done. I hope I got that in the camera. Yeah. Okay, time to put them in the connector. Now these connectors are polarized. If you look, you can see a positive and a negative indicator on the connector. Okay, just make sure you put your red wire in the positive and the black wire in the negative. And if you ever need to take these out, let's say you wanted to make a longer piece of wire and needed to get these out of this connector so you could reuse it, see those tabs that are sticking up in there? Not sure if you guys can see those or not, but you can take a screwdriver and press those down, and then you can pull the terminals out the back, because there's a catch. Right. Yeah. See that lip right there? It catches on that little spring that's inside the connector, and that's what holds it in the connector. So by pushing that spring down, you can pull this past it and get it out. Alright, let's see. And you'll hear it click when you shove it all the way up in there. I'm telling you all this because I don't send the other end of the cable with the amps. You have to provide that yourself, or you can order it from us. We do supply the cable, but I'm quite certain that most of you prefer to do your own cable. Okay, now turn it around here where you can see both ends. See how the terminal has pushed that spring down? That spring is caught behind the lip of that terminal, and it's damn near impossible to get it out without compressing that spring. Okay, and these are 120 amp. It's going to be upside down, but maybe you can read it. Right there, it tells you what the amperage rating of the connector is. This is a 120A, or 120 amp at 600 volts. Okay, more than enough for what we're doing here. Okay. Alrighty. There's the connector going to the amp. Getting ready to check the amp out now. More to come. Okay. Here is your sideband bias circuit. Now this makes the makes the amp class AB biased when the SSB switch is turned on. The SSB switch energizes this relay. Okay. Here's our SSB delay capacitor. There's at 2200 microfarad. Alright. And what this does, we're taking a voltage, the DC positive voltage, bringing it into a voltage regulator. Okay, this is nothing more than a 5-volt regulator. We're dropping the voltage through this pack of resistors down to 20 ohms. Okay, and here is our biasing diode there. Now this is, you can see all of this. This is a modified circuit from the EB63. All you amp guys know what EB63 is. It's the technical specifications for bias that was generated by Motorola. And the can't remember what they call the sheets now, but it's like a study sheet or a suggestion sheet that they used when they were doing experiments. The EB63 was the biasing sheet. Okay, so what this circuit does is change the bias to class AB when this relay is energized. It puts a low voltage on this wire, okay, which again is dropped by a 4.7 ohm resistor. Okay, goes through the power wire to the back of the transformer, input transformer. Alright, this puts a little bit of bias on the base of the transistor right there. Just a little. That's what makes it class AB when that relay is energized. Now when the relay is turned off, there's no bias on the base of these transistors other than the ground reference going through these little 10 ohm resistors here, which makes it class C. Okay, class C is basically on all the time. The transistors are running a full 360 on the waveform. Class AB chops that up. Anyway, I know that's too technical, you guys really don't give a crap, but with class AB, sideband works better because sideband is carrier suppressed. So there's no carrier coming into it all the time. Anyway, enough of that. And I'm still using these standoff terminals to mount the components with, and I'm doing that to stabilize the circuit. Okay, we've got a capacitor also attached to the input resistor. Okay, that's just good electronic building design. You know that those capacitors there make things more stable. All right, same thing over here. We've got the 4.7 feeding the supply wire, and this wire, you notice, is twisted around a toroid, and that's to stop the RF from moving back through the circuit. We're putting that low voltage on the input transformer, which puts the low voltage on the base of the transistors. But now that's only when this relay is energized. Okay, if the SSB switch is turned off, that relay is not energized, and we're running class C. Okay, more to come. Okay, so I got a 500 watt slug on the RMS side, and I've got a 1000 watt slug on the peak side. Okay, the peak side is set to ×1, so we will be reading on that bottom scale. Where it says 40, that's 400. That little mark between the 40 and the 60, that's 500. Okay, this one we're going to be reading on the center scale. Where it says 30, that's 300. Where it says 20, that's 200. Okay, I'm using just a regular old CB radio. Okay, right now I'm in AM, and we are not on channel 20, folks. We're like way up in 10 meters. Well, not way up. We're just inside the phone band there. Okay, so alright, I'm on AM. SSB switch is off. Now I don't want to keep this key too long because the fan's not hooked up. Okay, we're dead keying about, I'd say 280 watts RMS. And audio. Now that's the radio that's backing up, not the amplifier. I don't have a way to turn the AM power down yet. I've got to go in and put something on the radio where I can do that. But right now AM is turned all the way up on it. I'll probably use the squelch control or something so I can turn that down. But anyway, with about 7 watts in, it's doing about 270 watts dead key. But the main thing we want to look at is the peak meter. Audio. That's a little bit over 400 watts peak. Okay, that's pretty damn good out of 4 2290s. Alright, let's go to sideband now. I'm on the lower side. Actually, I need to be on the upper side on this band. Audio, hello, audio. Audio. That's real close to 600 watts. And what was that? That was audio. About 300 and, let's see, 10, 20. About 320 watts RMS. And real close to 600 watts peak. Out of 4 2SC 2290s. Audio, hello, hello, audio. Audio 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Okay. Okay. Got the spectrum analyzer hooked up. We're starting at 5, let's see, where is the start frequency? Start frequency is 5 megahertz, stop frequency is 53 megahertz. So our center frequency is about 29. We're in the 28 megahertz band. There it is right there. Beautiful. No side spurs. That's outstanding. Okay. Now let me put this in sideband. And let me put a little juice in the sideband there so you can see what the modulation looks like. Audio, hello, hello, audio. Audio 1, 2. Audio, hello, hello, audio. Audio 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. That's outstanding. Okay, you can see I was in lower sideband there. Alright, all I got to do now is put all the decals on it and get it out the door. More to come. And we made that power on 13.8 volts. Okay, Kevin, here it is, buddy. And all the decals on it. Now you guys probably noticed that when I put the toroids on the power and ground wire, I used hot glue to hold those toroids up against the back there. But the glue that I use is industrial hot glue. It's not hobby hot glue, okay? And it's not the same kind of stuff they seal up cracker boxes with. This takes more heat to melt it, to make it hold. Alright, so it's not going to turn loose back there. Alright, there it is, Kevin. Kevin, I sure hope you enjoy your new amp. It was my pleasure to build it for you. 7-3, everybody.